Hello everyone, and welcome to the lecture on text analysis. In this lecture, we'll see how to represent text in numerical formats. We'll see how to vectorize our dataset and convert it into a documenter matrix. And finally, we'll look at model building and evaluation. As usual, we start by importing the libraries that we need. Import numpy as np, pandas as pd. I copied this from one of our previous lectures. Before we get into text analysis, I want to review by looking at the iris dataset. So let's start by importing our iris dataset from scikit-learn. So from sklearn, we'll import iris. From sklearn, import datasets. And then we'll import iris by using the load iris method. And I'll save it in a variable called iris. Iris is equal to datasets.loadIris. And we know that our iris plant has 4 features: sepal length, sepal width, petal length, and petal width. So we can call the data method on our iris dataset. And let me save this in a variable called x. And we know that we can call the target method on our iris dataset also. So target will be one of the 3 iris species, right? Setosa, versicolor, or I forgot the third name, but those are our targets. So if we check the shape of this x and y, we'll see that x is a 2-dimensional array. Let me show you. Print x.shape. So it's 150 by 4, right? 150 rows, and then by 4 columns, which are the features: sepal length, sepal width, petal length, and petal width. Whereas if we print the shape of y, we see that it's a 1-dimensional array, 150, right? Those will be one of the 3 iris species. Okay, next let's create a data frame to represent our iris dataset. Okay, and I'll save our data frame in a variable called iris. So pd.dataframe, and then we'll create our data frame from our x, which is 2-dimensional array, 150 by 4. And then for our columns name, we'll simply pass the names of our 4 features: sepal length, sepal width, petal length, and petal width. For that, we can use the method known as feature names. Now, if we check out our iris dataset and call the head method, we have sepal length, sepal width, petal length, and petal width. And again, each row represents a single iris species. And as I mentioned, y is 1-dimensional. It represents either one of the 3 species. So if I simply print y, I'll get an array consisting of 0, 1, or 2. So 0 represents 1 iris species, 1 represents the second iris species, and 2 represents the third iris species. And based on this, we can build a model to predict which iris species a given observation is. And we know that in order to build a model, all of our features must be in number format, right? So our model algorithms work on numbers. So it's important to have our features in a numerical format. And we can build a model by using this iris dataset. So we have our x and y, right? We can define a model and then fit our model with x and y and try to predict an iris species from there. Okay, I will not do that in this lecture, but I just wanted to give you a brief overview. Great. Now let's go into text analysis. Let's consider the following text. I'll create a list of texts and save it in a variable called train text. And let's say we have the following text: go home tonight, go take a cab, soccer, go play soccer. Okay, let's try to analyze these three texts. We have go home tonight, go take a cab, and soccer, go play soccer. The first thing we need to do is convert this text into a number format, into a numerical format. That way our algorithms can work with those. Okay, so that's one challenge. The other challenge is our texts are of different lengths, right? If you consider this is of length 3, the second one is of length 4, and the third one is of length 4. And I'm ignoring the punctuations. So for our algorithms to work, all of our documents have to be of the same length or fixed length, right? First it has to be in number format and they have to be of the same length. Okay, that's what we'll do next. Transform this text document into a numerical format and then find out ways to make it of the same size. Okay, and for that we'll be using what's known as Account Vectorizer. Okay, the purpose of Account Vectorizer is to convert our text document into a matrix of token words. So if you go to the Scikit documentation here, Account Vectorizer, what it does is it converts a collection of text documents into a matrix of token counts. Token means words. Okay, you can read more about Account Vectorizer here. Okay, back to our notebook. Let's use Account Vectorizer to convert this words into a matrix of word counts. The first thing we need to do is import Account Vectorizer from scikit-learn. Let's do that. So from sklearn.feature-extraction.text, let's import Account Vectorizer. And then let's instantiate our Account Vectorizer. And I'll save it in a variable called vector. Vector is equal to Count Vectorizer. Okay, so this Count Vectorizer, it's not any kind of model. We only use Count Vectorizer. Its purpose is to convert our text into a number format. Now that we have instantiated Count Vectorizer, the next thing we can do is fit our Count Vectorizer object and then pass our trained text. So for that we can say vector.fit and then pass our trained text document. So this fit method is used to learn the vocabulary of our trained text document. Okay, now it has learned the vocabulary of our document, right? And then let's see what it has learned. Okay, and there's a method known as get feature names. Let's call that method on our vector object. So vector dot get feature names, and then run it. So this method returns a list of strings. So here we have cab, go, home, play, soccer, take, and tonight. Right? What do you notice from this list of words? So compare this list of strings to what we entered here and tell me the difference. So let me type our train text object here. So there are a few differences. One is here in our vector object, all of our strings are in alphabetical order, right? Cab and then go, home, play, soccer, take, tonight. So that's one difference. Another difference is there is no duplicate, only one word, right? Whereas in our original text document, we have duplicates. And the third difference is we don't see any punctuation keys in our vector object, right? So here exclamation and all these dots are dropped in our vector object. Okay, great. In the next lecture, we'll continue our analysis of this text. Thank you, everyone.